All right, so questions from the assignment, starting with number 21. So here we're given P, Q, and then angle R. Okay. So first thing I want to do is I want to check to see what situation I'm in, so whether I'd be using the law of sines or cosines. So this is the side angle side situation. I can tell that without having to draw the picture. You could draw the picture to tell. But I can tell without drawing the picture because the side that's given is not the same label as the angle. If one of those was angle R, I would know it would be the side-side angle situation. But this is a law of cosine situation. So the first thing I need to solve for is side R because I don't have enough information to deal with anything else. It's a bad-looking 3. Okay. And this I can just type directly into my calculator. And I'm going to do this all in one line. And because I'm looking for just R, I'm going to start with the square root. Ella, so far so good? Okay. It's 30 times cosine 66. So that's going to give me 28.1, let's call that. Sound good there? Okay. Now, when I'm doing the law of, when I'm dealing with a side angle side situation, when I go to solve for the angles, I want to find the smallest angle first. So I'm going to be looking for angle P next. And that's important. If you were trying to find the other angle, you potentially could have been running into some problems there, which is my suspicion as to what was going on. So again, that's when we're dealing with side angle side, you find the smaller of the two angles first. In the side, side, side situation, we find the biggest angle first. So just to rehash that. All right, to solve for P, I'm going to subtract 30 from both, or 30 squared from both sides, and then 28.1 squared from both sides, and then divide by 2 times 30 times 28.1, and then take the cosine inverse of both sides, and that'll give me P. And again, I'm going to do that all in one line on my calculator. So cosine inverse, and then I like to do the fraction command because it's hard to mess up my parentheses and stuff on my calculator when I'm doing that. And I'm going to use, rather than 28.1, I'm going to use the full decimal for my calculator. So if I press second and then the negative symbol, that gives me the answer command, which is just whatever the last output my calculator had. So when I do that, I get 11.4. Or I'm sorry, 11.24. Let's just call that 11.2 maybe. And then to find, what's the other label? Q, then I can just do 180 minus P minus R. So 180 minus that previous answer minus 66. So I got 102.76. Ben. For where I solve for P, yeah, you could have used the law of sines there also, sure. Yep. Yeah, you had to use the law of cosines as your first step, but after that, you could have used law of sines there also.
And if you use law of sines, you take the sine inverse.
Yes, you'd be needing to use sine inverse to get the angle by itself. Yes. That's correct. Okay. Ella, you happy?
Yeah.
Okay. Other questions from this assignment? Sydney? 19. Okay. So again, first thing I want to do is check which situation I'm in. Just like the previous one, this is another side angle side situation, so I'm going to have to start by using the law of cosines to solve for side C. And I can just type all that mumbo jumbo into the calculator. So that gives me 18.41. Or, sorry, 42, I guess. So far, so good. And then just for something different, as Ben suggested, we could use the law of sines here instead of the law of cosines. That's fine to do also. So let's do that. Again, we want to solve for the smallest angle. So I'm going to solve for angle A here. So if I cross multiply, divide, and take the sine inverse, I'd have this. And again, I like to use this fraction command. It just kind of makes life easier than having to mess around with like 1,000 sets of parentheses here. And I'm going to use the full decimal from my previous answer. So that gives me 32.83, I guess. I don't remember how many decimal points they asked around this to. So there's my value for A. And now to find my value for, is it B here? Yeah. I can just do 180 minus A minus C. And when I do that, I get 60.17. Does that make sense, Sid? Yeah, you're welcome. Brock Tone, did I see your hand up earlier?
Yeah, can you do 15?
15? Sure. Okay. So easy to see this is the side, side, side situation since you're given three sides. So in the side, side, side situation, I want to find the biggest angle first. So I'm going to find angle C to begin with. So again, to solve for angle C, I'm going to subtract 12 from both sides, or 12 squared, excuse me, and then subtract 15 squared from both sides, and then divide by 2 times 12 times 15, and then take the cosine inverse. Oops, that's not the button I want to press. So cosine inverse of the fraction 20 squared minus 12 squared minus 15 squared, negative 2 times 15 times, 12. I guess I did that in a weird order, but whatever. So I get 95.94. degrees there. That's right. Didn't I copy? Oh, 94.94. Okay. Okay, so far there, Brox? Okay. Okay. So yeah, I think probably you just had some typo then. And then from there, you can use the law of sines to find the next angle, doesn't matter which one. And then you can do triangle sum to find the last one. Bella?
For like the work, how you showed it, like when you subtracted the 12 squared and 15 squared, and then divided. I did that like multiple problems, and I was getting the wrong answer, so I started just doing it like all at once. Like even though you said like not to do it all at once, like a few days ago.
What do you mean,
There's,
do
like,
it all at
possible
once?
Error, like put it all in your calculator, like just like the 20 squared equals the 12 squared plus 15, like the whole step above.
Oh, you wanted to like do simplifying as you're going?
Yeah, if I did that, is that okay?
Yeah, I just have found that it gives students problems when they do that, so I recommended not. But if you're doing it and it's working for you, that's fine.
Okay.
Okay, not a big deal. Ella?
Can you read your answer for number 20?
Yeah. So the answer for number 20, side Z is 26.02. Angle X is 29.26. And angle Y is 48.74. Brockton. I mean, I guess I did on these problems. There wasn't an instruction as to how much you wanted to round. So whether you went 1 decimal place, 2, 3, whatever, you should have given me at least 1 though, hopefully. But yeah, I wouldn't be picky in this. I'd be specific if I cared, kind of thing. And on the test, I would certainly be that specific for you. Yeah, no problem. Decent questions. Anybody else with questions about this? Okay, great. Next up, we as a class are going to prove the law of cosines together. Yeah, as a team. Oh, can you just... Let's see. Did I pull this out? Not yet or no? I did not. Get it from there then. Did I give you an extra? These were so sticky. I had such a hard time. Whatever. You don't have to patronize me. All right, start. Well, I don't even know what's going on. All right, whatever. All right, So look at what we're being asked to prove on your sheet. So this is just the law of cosines, right? We talked for a moment yesterday about the law of cosines and about what other thing it looks similar to. Do you guys remember what we said there? The Pythagorean Theorem. Excellent. In order to use the Pythagorean Theorem, what do we need to have? Right triangle. Yes, very good. So let's look at the picture we have right now. We don't have a right triangle. So we're going to try to chop this triangle up into two right triangles, just like we did when we derived the law of sines. The question becomes, where am I going to draw my altitude in at? Am I going to draw it from angle A, angle C, or angle B? C. Very good. Why C? Well, which angle do I care the most about in the formula? A. Which side am I going to care the most about in the formula? A. So what don't I want to chop, or what don't I want to make sure I chop when I draw this altitude? Side A or angle A, right? So definitely don't want to draw my altitude here. Drawing either from C down or from B over, either one of those would be okay. But seems most convenient to do this. Everybody okay with that plan? Okay. So we'll do that, and we've made two triangles. So I've labeled my two triangles, triangle 1 and triangle 2 there. Let's look at triangle 1. What is the base of that triangle going to be? So it's not C. C is the length from A to B, right? You can do it with one letter. So the thing that nobody is looking at that you would need to look at to answer this question that I'm asking are the coordinates. So look at the vertices. We've given each of these each vertice a coordinate there, right? X. Very good. So this side here is X. Everybody see Y? Okay, what's the height then of triangle 1? Y. Go ahead and add those two labels. Now let's look at triangle 2. We know the height of triangle 2 is Y, right? Because it's common to both triangles. What's the base of triangle 2 going to be? C minus X. Yes. Now it's appropriate to say that. Everybody good? Okay. Now it's Pythagorean Theorem time. So use the Pythagorean Theorem on each of the two triangles. Go. You do this. So we should have this, right? When you applied the Pythagorean theorem to each of your two triangles. Everybody okay there? Do you see something in common between these two equations? Y squared, right? So let's get the y squared isolated in at least one of these two equations, and then substitute that into the other. Everybody okay there? I substituted in for y squared. Why did I substitute the left equation into the right equation instead of vice versa? I want the a squared by itself. So that's why I chose to rearrange and substitute the way I did. Could you have substituted the other direction? Yeah, you just have more rearranging to do at the end, but this is going to be a little bit quicker. Okay? Now what do you guys think we should do? I have the a squared. That's good. I have the b squared. Somehow the rest of this stuff I need to get a plus a c squared and minus a 2bc, right? Cosine a. Ben? Yeah. So let's expand that out. To expand that out, we have to FOIL though, right? Everybody's good there? Look at what's going to happen here when we combine like terms. The x squareds cancel out. That's pretty nice. Question, Maya? Or are you stretching? Okay, that's fine. So we're almost there. We almost have what we want, right? Somehow, though, this x has to turn into what? B times cosine of a, right? So let's go back and look at our picture and see why x would have to equal b times cosine a. So look at this triangle. What's cosine A equal to? How about adjacent over hypotenuse? If I multiply both sides by b, I get a value for x, right? Is that exactly what we needed? It is. It is. And we're done. That's the most obvious way to do this. There's another way, but I'm not going to.
Could you go back up to where you wrote that?
What do you guys think? It's all right, huh? Not as bad as maybe you thought? Did you like getting to participate a little bit? Just a little bit, right? Next up. So here is just some more practice on solving triangles. We'll take the remainder of our time here today in class to let you guys work on this. Not a bad deal. If you have questions on things or want to check your work or any of that good stuff, feel free to come on up and say hi, and I'd be happy to help you out or let you check or whatever you need to do. Sound good? Yes, probably by tomorrow.
Why are there always hands? Oh my god. I'm serious. I'm very I really do not like that.
Yeah, because you know they bite somewhere.
Yeah, I do not like that. Where are they?
Yeah.
I don't want to see them. Oh my god! Yeah. My bad.